We've already talked about atoms in the past, but just as a reminder, all atoms are neutrally charged. That is due to having an even number of protons and electrons. If you have the same number of protons, which are positive, and the same number of electrons, which are negative, then of course they'll cancel out, resulting in something that's neutrally charged. But let's think about maybe carbon. Let's say that carbon has 6 protons and 6 electrons. And let's think about the possibilities here of how we could make it where these number of protons and electrons aren't equal. Well, if you change the number of protons, let's say this has 5 protons. This isn't really a possibility within just the field of chemistry because you've changed the identity of this element. We know that if you have 6 protons, you're carbon. But if you magically somehow change to 5 protons, you're now boron. You've changed the identity of this element. So because of that, it doesn't really make much sense to try to change your number of protons. But it is within the realm of possibility that maybe we were to lose an electron, or let's say even gain an electron. In either one of these cases, you have 6 protons and a different number of electrons, meaning this will no longer be neutrally charged. We call that an ion. An ion is a charged particle and we're going to simplify this a bit for now, but it's a charged particle due to having an unequal number of protons and electrons. Due to unequal number of protons and electrons. So it then goes to think that, well, an ion could be positively or negatively charged, and you're right, we need to identify and define those. So we'll start with what's called a cation. A cation is a positively charged ion. This is easy to remember because a cat has paws and a cation is positively charged. Yes, hysterical. Well, the opposite of that is called an anion, and anions are negatively charged. So if you start to think about how these are formed, it's actually almost a little backwards of what most people would envision. We said previously that if you were, let's just say fluorine, with your 9 protons and your 9 electrons, you're electrically neutral. But in order to become positively charged, we can't adjust our number of protons. We can only adjust our number of electrons. Since an electron is negatively charged, envision losing this electron. You now have 8 electrons. Well, you have 9 protons and 8 electrons. That gives you a net positive charge, meaning cations are positively charged due to losing 1 or more electrons. So I know it's a little bit backwards, but you lose an electron which is negatively charged, and that turns you into a positively charged ion, a cation. So cations are formed due to the loss of an electron. But let's go back down here and let's start over. Our fluorine has 9 protons and 9 electrons, but instead, let's say we gain 1 electron, so now we have 10. Well, now the negative charges are overpowering the positive charges, so this gaining of this electron has actually resulted in a negative charge. So anions are formed due to the gaining of 1 or more electron. Now, we won't dive too deeply into it here, but you can actually predict the charges of the elements across most of the periodic table. In order to achieve stability, like the noble gases over here on the far right side of the periodic table, those noble gases are stable, so we can say that atoms are trying to achieve stability like them. Well, if you think about the halogens right here in group 17, they're only 1 measly electron away from matching their noble gas in order to achieve stability. So all of the atoms within that group will gain 1 electron, giving them a 1- charge. If you go over one more group, these are only 2 electrons away from being the same electron arrangement as the noble gas, which will give them stability. So this entire group just needs to gain 2 electrons, which would give them a total of 2 minus charge. That just means they have 2 more negative particles than they do positive particles. And this trend continues here in group 15. Oops. They're going to gain 3 electrons, and I'll have 3 minus charges. Okay, so down this whole group you got 3 minus, down this whole group you got 2 minus, down this whole group you got 1 minus charges. And we're not going to dive too deep into it here, but if you think about this group 1 over here, this guy right here would need to gain 7 electrons in order to match the electron arrangement of its closest noble gas. Instead, we can actually work backwards, and if he'll just lose 1 electron, he will match the noble gas that occurred previous, meaning this entire group here will just gain 1 electron. Down this whole group, we can anticipate that these will form 1 plus charges. Down the group next to it, they will lose 2 electrons in order to achieve that noble gas configuration. And over here, they will gain 3 down this whole group. So you can use this breakdown to predict the charges that the elements within these 6 groups will make. So if we erase these arrows, and we just pick one of these at random, let's just say this guy right here, I don't even really need to know what element that is, but I know that since he's in this group, that makes 2 minus charges. This guy will make a 2 minus charge when he becomes an ion, which means he has gained 2 electrons. If I picked one right here, again, I don't even need to know what element it is. It's in the group that makes 2 plus charges. This will make a 2 plus ion because it will lose 2 electrons. So you'll notice, if you follow the little stair step here, the elements on the left side of the periodic table tend to make cations that are positively charged, and the elements on the right side tend to make anions, which are negatively charged.